the units of work and energy. So the units of work and energy are really the same thing. So we could imagine that we have a single coin. You can't separate the heads from the tails. So when you have the energy coin, one side is work, the other side is energy. They're really one and the same. So if I look at just the units of work, what do I know? Well, I know that work is force times distance. So then I have a unit of force, and this is known as a Newton. And then we have a unit of distance. And in the metric system, we know that that is a Newton and a meter. So when I now look at a unit of work, it should be a Newton times a meter. And this is what we call a joule. And a lot of times we call 1 joule, just we use J. But most of us don't know what a joule is. And the reason why is that the common unit of work in the United States is the food calorie. And if you're in industry, they'll call it a foot pound. But most people know the common unit of work as the food calorie, but you probably don't call it a unit of work. You'd say it's probably energy. It's calories, right? That's the common word that people say, I need calories. Well, what does that really mean here? So in this case, here's what we find. So 1 food calorie which I'll write as 1 big cal, is approximately equal to 4,000 joules. And this is the number that we'll use to make sense of everything. So the question that we want to ask is, how large is a joule of work? So remember that in this case, we're going to use the weight of a stick of butter. And that guy is about 1 Newton. So imagine that you have a stick of butter, right? Here's your stick of butter. And what you're going to do here is that you're going to lift this stick of butter all the way up to here, right? So, and so this is the butter. And what you're going to do here is that you're going to apply a force. So as I apply a force, because this is a stick of butter, your force that you're going to apply is 1 Newton. Why? Because that's the weight of a stick of butter. And what you're going to do here is that you're going to lift this thing now. You're going to go from here all the way up to right there. So the distance in this case has to be 1 meter, but wait a minute, 1 meter is about 3 feet. How much work does it take to lift this stick of butter? Right? If I ask you how much that is, you're going to say that not very much. So when I look at the work of this guy, the work then that you did in lifting this bucket, this stick of butter here, which we already know is force times distance, has to be what? You're going to lift 1 Newton, which is the weight of a stick of butter, and you're going to lift it 1 meter. And so this means that that was 1 joule of work. It's not very much, but that's what we're talking about. So the example that we want to hit on Wednesday, to give you a sense how much work 1 food calorie is, we want to look at milkshakes. From Baskin Robbins. Baskin Robbins. And what you find here is that I looked for the biggest one. And you can get a shake that has roughly 1,500 calories. So we want to look at those details. And we said that the most common unit of work that people talk about on a daily basis is without doubt the food calorie. And I'm going to show you that the food calorie is an enormous, enormous amount of work. Not a little bit. We're talking a lot. And so to get a sense of what a food calorie is or what a joule is of work, you have to lift a stick of butter up 1 meter, which is about 3 feet. And if you do, that's 1 joule of work. And so what we wanted to do here is that to give you a sense, by the way, I could do this with a can of soda. Even a can of soda is an enormous amount of work. A can of soda has 150 calories. And good God, it's an enormous amount of work. So what we want to do here is that we want to go in and we want to look at what does it mean when you drink a milkshake and then you say, I'm going to go work it out. Okay, how many times have you heard that before? Here we go. So let's start. Let's set up the situation here. And this is where we end off last time. So, I think I'm going to go here. I've already set this up because I don't want to write new information on an old sheet. So this is exactly the same place as the other one. So here's the situation now. After drinking this Baskin Robbins milkshake, you feel guilty. And then you say, I need to go to the gym to work this off. How many times have you heard something similar to that? Okay, so let's say that I go to the gym, right? I drink the milkshake. So then Carlos decides to bench press off the calories. I don't want those calories, so I'm going to do the bench press. So what I'm going to do here is that, so I'm going to set up a bar system. So imagine that this is my bar system, right? And I'm going to be lifting these bars. So yeah, I'm going to be lifting these bars. So the question is, how much weight is this thing? So I'm going to say that the weight of this guy is 160 pounds. So I'm going to bench press 160 pounds. And what's nice about this number, it's about 700 newtons. So 160 pounds is equivalent to 700 newtons of weight. And so what we know here is that what I'm going to do here is, of course, is that I have to lift this weight slash bar up and down. Okay. Question. How many times does Carlos have to lift this weight to burn off 1,500 calories? That's really the question that we're answering. So now that we set up the question, let's go do it. So what we want to do here is that we want to get into the lifting phase. So if I'm doing the lifting phase, what does that mean? What that means is that I start with the bar, where? Right here. Right? There's the bar right there. So when I'm looking at this bar, I got to lift that guy up. So how do I lift that up? Well, I have to push up. How much strength do I have to apply to lift this up? Well, my whole body has to lift up what? With the force of 700 newtons, right? I have to lift up 160 pounds with my body. So then I'm going to say here is that I lift this guy up this distance right here. Right? That's where I lift it to. So then the question is, how much can you lift this? So what I did here is I just used me, and I know that if I push up all the way from here to there, that's half a meter. So that means that my distance as I go from here to there, that distance is half a meter. So what does that mean? How much work is this? And the answer is, we know that work is force times distance. So then I know that I did what? 700 newtons, right? That's how much I had to lift. And then the distance that I did was half a meter. So when I look at the total of this thing, this is going to be 350 joules. And that's how much work I had to do to lift this thing up. So now I have my number right here. But then there's the lowering phase. I got to bring the bar down because I got to go up and down. So now I have the lowering phase. So if I look at the lowering phase, my bar starts up where? Well, it starts up right here. And what I'm going to do here, of course, is that I got to lift it. Now, how do I lift? How do I bring down the bar? Well, for starters here, I still have to apply the exact same force going up. We don't want to pull the force down, right? We don't want to force this thing down. You'll get hurt if you do that. So in this situation here, we are purposely bringing it down. So when I look at this distance, that distance is going down. But we know that that distance is still half a meter. So then again, I ask, how much work is this? And when I look at the work, it's still going to be what? 700 newtons. And I still have the exact same distance. It's just that now it's in the opposite direction. And when I calculate this, you see that the work down is 350 newtons or joules again. So what this tells me here is that my body's total amount of work is, it's got to be the work up plus the work down. So it's got to be 350 plus 350. This is going to give me 700 joules of work. And this is for one lift up and down, right? One lift. Okay, one lift. Okay, so this is a big deal. That's the magical number. So what does this thing mean right here? Okay, 700 joules means how much, or not how much, or how about how many calories were burned off for a single lift. Right? That's how many food calories I burned off. So now we have to ask the question. How many calories is 700 joules? Check this out. A single lift burns 700 joules. And when you convert this to calories, it's 0.2 food calories. That is an important number. So 700 joules is not even 1 calorie. That has to be disturbing. So when I look at this thing, I now want to calculate the number of repetitions. Okay. So the number of repetitions or reps to burn off the milkshake is then has to be what? Well, we need the calories of the milkshake divided by a single, how do I say it? A single lift, or how about the work of a single lift. So that's what's going to tell me the number of reps that we have to do. So this is going to be 500 calories. And then we already know that this is 0.2 calories. And look at this number. This number is approximately 8,500 reps. But there's a little bit of a white lie here. Okay. So there's a little white lie here. What we also have to account for is that your body immediately takes 25% of the incoming calories to operate your body. So if I calculate what is 25% of this, so that means that 25% times the total reps is equal then to 2,200 reps. So that means that the actual number required of reps required is then going to be, turns out to be 8,500 minus 2,200, which means that this number now is 6,300 reps. Now, you gotta admit that number is an ugly, ugly number, right? So this is how many reps to burn off the milkshake, which is disturbing. In other words, you can't burn it off. It's impossible to burn it off. And that's why, I mean, it's obviously more complicated than what I'm, leading on to here. But what we find here is that it's disturbing that if you can make that kind of a statement, man, it just doesn't work that way.
How much time per rep?
Say that again.
How much time per rep?
Time? I don't know for time. Let's say it's 1 second. That would take you 6,300 seconds, right? If that's 6,300 seconds, I mean,